right, welcome to section 2, the first real section of the Scrape the Planet course. Like I said, my name is Mitchell Edwards. I go by VikingSec, Viking Dev, Viking, and probably all kinds of four-letter words on the internet. If you missed the introduction, I talk a little bit about me, about what I do, my experience, and what this class is going to be about. So I would definitely recommend going back to that. If you're watching this on YouTube, I'm going to post the link up in that corner, one of those corners. If you're watching it on Udemy, it's just the introduction section. So I've got the glove on. This glove means we're going to be whiteboarding. I've got the little pencil too. We're going to talk about the very, very basics here. And if you already have coding experience or networking experience or experience, you're going to feel tempted to skip this section. And you might be fine to skip it. I would recommend sticking around though, because we're going to talk about what are web scrapers in the context of this course. We're going to talk about some of the foundational technologies and ideas behind web scrapers. And then we're going to move on to the actual development. We're not going to get to code in this video, and I know that sucks. Trust me, I really want to be opening up the IDE as much as humanly possible in this. But we can't always do that. We kind of have to start with these foundations so that everybody's starting off on the same page. And I want everybody to start off on the same page because if we kind of get into the later chapters and we talk about complex stuff and you don't understand the basics, then you're going to be lost. So, the very foundation. What are web scrapers? To dive into this question, we have to have a basic understanding of how the web works. So, the www. Everybody's seen it, everybody knows it, everybody thinks that they know it. We're not going to dive into like the really nitty-gritty stuff. We're not going to be talking about DNS. We're not going to be talking about TCP, UDP, and all of the other complex networking stuff. We're going to talk about HTTP, and we're going to talk about how the web works from a foundational level, not like a super high-tech, in-the-weeds discussion about it, but a discussion about how the web works from the context of scrapers specifically. If you already understand the deeper concepts that I mentioned, the DNS and HTTP and TCP, UDP, that's great. It's going to help you because you're going to have a little bit of a deeper understanding, but understand that throughout this course, I'm going to be abstracting a lot of that away. This isn't a course on how like the internet works. It's a course on scrapers. So I'm mainly going to be talking about these subjects from the context of scrapers, and that means that there's going to be some abstraction, and I'm going to kind of leave some stuff out. So let's start with the user. That is you. So you are here, and you are using the web. You are the user. So when the user decides to go to twitter.com, they're going to open a browser, and that browser is going to be Chrome, Safari. I mean, nobody uses Edge, but theoretically Edge or Internet Explorer. It's like crappier, but still related cousin. But, you know, Firefox, Brave, Chrome, Safari, whatever. You open up that browser, and that's a very important piece of this, and you decide to go to, let's say, Twitter. And you're going to go up to the address bar and type twitter.com. That is Twitter's URL. That is how you're actually going to tell the browser to get to the website if you're browsing the web through a browser. Obviously, that's going to be important later when we talk about scrapers. The screen that you see that shows you tweets, trending topics, and you know all of the nasty DMs that you get because Twitter's a hell site, that's called the user interface or UI. We're going to call it UI a lot. So if you're on your laptop, just know this is not an art class. You shouldn't expect too much on that front. You open up your browser, and you're going to get, you know, something like this. And you're going to have a box and a bunch of tweets by people who all know better than you. And you're going to have your trending topics. So that's going to be like a really horrible depiction of what Twitter looks like when you open it up in a browser. Typed in your URL somewhere up here, and it took you to the website. Now, you made one request. You typed in twitter.com or twitter.com/Viking_sec. And now you see all of those tweets. You see all of the things that I like to talk about, all of the things that the other person likes to talk about. But there is so much more going on behind the scenes. There are hundreds or thousands of requests for every single web page that you load, just to load in the tweets, just to load in the pictures, just to load in the news. All of this different stuff that's happening on the page, it's not just one request. You're making one request, but there's so much more going on behind the scenes. The web browser handles those requests and responses. So you as the user are actually interacting with the Twitter server. And we're going to say it's just one, but in reality, there are probably hundreds. So that is the Twitter server. It's basically just a big box, because I'm not going to actually go like through the effort of like drawing out a server stack. I actually got one behind me that you can't see, but that doesn't matter. So you are making a request to the Twitter server, and Twitter is sending a response. This is basically, if I can spell, this is going to be the server-client relationship, where you are the client, you are the user, and you are making requests from the server. You say, hey, I want to go to www.twitter.com. You type that into your browser. So let's make a different diagram over here. This is still you. You haven't changed at all. You are still a wonderful, happy person over here. And you are using the browser. We're just going to make a really bad Chrome icon. Kind of looks like an evil eye, but that's accurate for Google, I guess. So you're using the browser to make requests to the server. Now you send one request. So that is a request. The browser sends that request on to Twitter server. But what actually happens is it sends a response, and then another response, and then another response, and your browser is sending another request, and another request, and another request. And this happens like literally as you're scrolling. As you're clicking, you're sending more requests to the browser. It's going to look very, very simple on your end. You're really just sending that one request, or that handful of requests. Every time you click a link, you're going to make another request, because it's going to request a different thing from Twitter server. The browser is going to handle all of those other requests. All of the other data that's being handled, all of that other stuff is being handled by the browser. And we need to be very thankful for that. We're actually going to show what actually happens behind the scenes. It's actually fairly easy to look at within the Chrome browser, Firefox browser, any of those. It's very easy to actually see what's going on behind the scenes that luckily we don't have to deal with. Now, these responses, let's talk about that, because that's fairly important. Let me make us some room here. So let's erase all of this, get rid of our user. You're still there, but we need a little bit of room to show this. So when your browser is making this request response kind of conversation with the server, what is actually being displayed to you is not what the server is sending back. So this is Twitter. Our browser is going to act as an interface between us. And we're just going to make one simple double-headed arrow here to show that it's like a conversation with the browser. Let's draw our evil eye Chrome icon and you. So what you're seeing is this web page that's got, all of this stuff on the side. You can type in your tweets about all of the important stuff that you talk about on Twitter. You're actually seeing this really nice page in front of you. But what your browser is getting is what's called HTML. HTML stands for the Hypertext Markup Language. And what that is it's basically code that the server is sending back to your browser that is just a bunch of like nonsense. And I'm going to flash up like an example. I think I'm going to use the example of like Google's very, very simple front page. And it'll show kind of like what the browser sees whenever the server makes a response to it. It's sending back this big block of code. And thank God we don't have to, like walk through all of this code to try to find the tweets that we're interested in. We get this beautiful UI that, thousands of people at Twitter have developed to kind of make sure that we're constantly addicted to social media. So we're looking at this beautiful depiction. The browser is looking at tons of code, and what the browser is it's an interface between you and the server to make sure that you don't have to look through all of this ugly code. You can just kind of look at the pretty UI that they've developed. All right, well, that's all cool. Now we know how the server talks to your browser and how you're able to see all of these pretty pictures and all of that. But what does that have to do with scrapers? And that's a very good question. Now we're going to kind of dive into what scrapers actually are. When you're navigating the web, you're sending one request, you're sending 2 or 3 requests every time you click a link. It's kind of low volume, and you're doing it compared to computers very slowly. Scrapers do all of that like that autonomously. They're clicking links, they're going to images and downloading them. They're reading through thousands and thousands of tweets a second, and they're doing all of this at the speed of computers. You're doing all of this at the speed of humans. You have to be able to type. Computers don't. They talk through text very, very quickly. That's what computers are good for. Computers are good for doing things very, very quickly, doing like repetitive tasks very, very quickly. They're good at remembering, storing, and analyzing data in kind of mathematical terms, not necessarily in the same way that humans would do them. Whereas humans are really, really good at kind of doing intuitive things to humans. Like, we're really good at writing books. A computer's not going to write Shakespeare, hopefully very soon. Humans are able to write, we're able to create art, and computers are able to store data and analyze data and make requests to websites. So what scrapers actually are is they're making all of these requests the same way your browser would, but way faster. And they're doing it with the brain that you build into them with Python or JavaScript or Go or whatever language you decide to use. We're going to be using Python in this course. So scrapers can be built in essentially a limitless number of ways. As kind of is the case with all programming, you're going to be able to come to the same answer in not necessarily a wrong way 1,000 different ways. It's like one of the things that I love about coding in general. Scrapers are the exact same way. They can be very, very tiny little like one-line bash scripts, or they can be like thousands of lines of code. They can be built to run 24 hours a day, 7 days a week. Let's just say you had this initiative. You really wanted to collect tons of tweets. So you've got Twitter servers, and it's serving up tweets. Let's just say you hire 6 people. 1, 2, 3, 4, 5, 6. You hire all of these people, and all they're going to do is mindlessly scroll Twitter, which honestly, those 6 people are probably going to do regardless, but they're going to do it for you. It's going to be their job to do nothing but scrape Twitter 24/7. They're going to be making these requests and having these same conversations with the server through their browser. They can only really read a couple of tweets a minute and really like digest it. You want to memorize this stuff. You want these people at the very end of the day to be able to report to you exactly what they read. So these people are going to have to memorize this stuff and write it down. They're going to have like this big running like Google Doc of all of the tweets that they've read, and they're going to go through it at the speed of humans. Now, in America, we have a very limited set of labor rights. There's probably a YouTube video to be made about that on some other channel, but we're not going to talk about the politics of it. We're going to talk about like the actual implications of there. You can really only work them a certain number of hours. You have to pay them a certain amount of money per person, and you're going to have to give them benefits, healthcare, sometimes stuff like that. So this starts getting costly. You start paying a lot of money per person, and you're not getting really great results there. Each person is going to make mistakes. They're going to forget to write down a tweet in the Google Doc, or forget to throw it into a database, and they're going to miss stuff. And humans are humans. We're not really great at that repetitive task stuff. Now let's take this whole situation, and instead of 6 humans, we're going to build a scraper. And it's going to be hitting Twitter. We're just using Twitter as an example right now. We're not actually going to be building a scraper for Twitter. And we're going to throw it on as many servers as we want. We've just got tons of these block-like servers out here. And all of these servers are going to be running 24/7, night and day. Only real cost you're paying is for hosting on AWS, DigitalOcean, whatever. You're not going to be paying their healthcare bill. They're not going to take time off, and you can be a lot meaner to them than you're supposed to be to human workers. These scrapers are going to be able to remember things like perfectly. All of this data is going to be written out to a database, or it's going to be saved on a file somewhere, and they're going to be able to remember it essentially forever. Unless there's this catastrophic failure at your data center, or the whole thing burns down, or you decide to delete some of the data, or you get ransomware. I mean, there are ways that it can go wrong. But essentially, all of this stuff is going to be remembered indefinitely forever. If you want to try to dig up a tweet from, 2011 where somebody said something really stupid, I hope that's not me. If you want to pull up a tweet like that, it's a lot easier to do it this way instead of asking, whatever employee that you've had scraping Twitter for, mindless, numbing amount of hours. So scrapers are the perfect solution for something like that. They gather lots of data very, very fast, and they store it indefinitely, allowing humans to do the actual analytical work that requires a little bit of intuition. That's essentially what big data is. It's the collection of that data, the storage of that data, and the analysis of that data. Machines can do a fair bit of that. Humans develop the scrapers, they develop the analysis, they actually take that data and make it something useful, but scrapers in themselves are what does the collection way faster, way better, and way cheaper. So, that is what scrapers are. They're essentially a better form of humans at scrolling through really dumb posts on Twitter. In the next sections, we're going to talk about two different kinds of scrapers. We're going to be talking about page scrapers and API scrapers. Later on, we're also going to talk about spiders, but we're going to start with these two foundational kinds of scrapers. This is still going to be a little bit of whiteboarding left. And, I promise we're going to get to the code eventually, but for right now, it's going to be whiteboard time. We're going to get into what page scrapers are in the next section. And the section after that, we're going to talk about APIs, because those are very important to scraping in general. And we're going to talk about API scrapers in that section as well before we get into the ethics and legality of web scraping. I promise, after the ethics and legality of web scraping, we're going to actually get to scraper design concepts. Scraper design concepts, still going to be a little bit of whiteboarding, but we're going to talk about things that are a little bit closer to the actual code itself. We're going to spend probably 2 sections on that scraper design and whiteboard essentially throughout the whole time. And in the next section, in section 3, we're going to actually get down to writing code. Please, please, please stick with me through this. The foundational concepts of design, the ethics and legality, it's not sexy. And I understand you want to get to the sexy part. But we kind of have to get through these foundations first, and we'll eventually get there, I promise. Thank you so much. I look forward to seeing you in the next section.